Now, as we mentioned in section 1 of chapter 4, graphing is challenging if you don't have good graph paper and but MATLAB lets you graph very well. But are there other systems of solving systems of linear equations? And the answer is yes. So in this section and in the next section, we're going to go over uh, two other ways of solving it. And this is solving systems of linear equations by substitution. All right, there are some basic rules in this as we look at it. And it makes sense too. Now here we have in example 1 a system of equations. There's two equations. Notice this is the first. This one happens to be in standard form, which is nice. But this second equation, notice we have solved it for the letter y. Oh, how about x? Solved it for the letter x. Now, what can we do with this? If we say that x has this value, we can take this value of x and put it in the other equation. That is, substituting this value for x in terms of y in the other equation. So what we're going to do now is put 2, there's the 2, and we're saying that our x is this, so we put that in parentheses, y plus 2, and then our other y plus y equals 10. We now have an equation with only one letter. Here, these have two letters, x and y, but now this one only has one, so we can solve that as we would a regular equation. 2y plus 4 plus y equals 10. Now we combine our y's and we get 3y. And we subtract now 4 from both sides and we get a 6. Then we divide both sides by 3 and we get y equals 2. So we now have the first member of our ordered pair, which is the 2. Now what do? Well, we take this 2, go back to the original equation, and put the 2 where the y is. You could use either one, but I'm using this one. So 2 plus 2 is what? 4. X equals 4. And now instead of graphing it, I've used the method of substitution, where I solve for one letter, take that value, put it in the other equation through substitution, solve for that letter, get a result for that letter, then put it in either of the original equations. Okay. Now again, all of this is written up here, and it's just a matter of you to look at it and pick it out. And if they were to check it, it works. And if you were to graph it, it works as well. And there's just another example that you could work. All right, let's do example 2. Now, here we see y now has been solved. Y is, they're saying, is 3x. So we're going to take this 3x and put it in the other equation where the y is. So we now get 5x minus, now this is critical, your y is 3x equals negative 2. So we group like terms, we get 2x equals negative 2. Divide both sides by 2, we get x equals negative 1. We now have the x member of our ordered pair as a negative 1. So we go to our equation. 3 times negative 1 will give us a negative 3. So there's our ordered pair. And they've worked it out for you as well. And the method we used, substitution. And the key was you solve for one of the letters. Then take this value, plug it in where that letter is. You now have an equation with only one kind of letter that you can solve in the regular way. Oh, wrong one. All right, let's go on. Now, often the way they will appear is as you see it in example 3. The others were sort of easy. They already solved for one of the letters. So here we have two equations in standard form. Now as you look at this, you see the x there. So we're going to solve for x all by itself. Transpose that becomes a negative 2y plus 7. I just took my 2y from this side, transposed it to the other side, changed its sign. Now I get 2 times, what did I say x was? A negative 2y plus 7 plus 2y, that's this one, equals 13. So now I distribute, I get a negative 4y plus 14 plus 2y equals 13. Now I group like terms. I'm going to get a negative 2y. Transpose this positive 14 to the other side. On the other side, it gives me a negative 14, and a positive 13 gives me a negative 1. I now divide both sides by a negative 2. I get y equals 1/2. Oh, okay, we got a fraction. So I go to my other equation up here, and I'll say x plus 2. Now I put my y in there, which is nice, because it's going to cancel out, equals 7. So I do this multiplication. This just becomes a 1. So I have x plus 1 equals 7. I transpose the positive 1. It then becomes x equals 6. So my ordered pair then is 6 and a 1/2. Wow. Okay, so this is more typical of what you can expect to find. Two equations in standard form. Let's go on. And there's our answer. And again, you could look over this in your textbook. So here's a little summation then of how to solve using the substitution method. And step 1 is to solve one of the equations for one of the letters, either X or Y. Then you substitute that expression to replace that letter in the other equation. And then you find that one, put it back in the other, and you can read this over. Okay, example 4. Again, both are in standard form, but I see I have a y right here. So I'm going to solve this equation for y. Y equals, transpose the negative 3x becomes a positive 3x plus 6. And I guess we can use their work on this too. I could do it, but it's all written out and you can study it as you go. So there you have this. Now you're going to take that value for y, and in the other equation where that y is, you're going to put it there in parentheses because you're going to have to multiply through. And then grouping like terms, transposing, you get your first term, x, is a negative 2. Now notice when you get it, and since you've solved this one for y, x is a negative 2, you can just put it right in here. Y equals 3 times, you say x is a negative 2 plus 6. Now notice this becomes y equals negative 6 plus 6, or y equals 0. Students get a little nervous when they see this, but again, this is a good one. Y equals 0, perfectly okay. So what will your solution set be, or your answer, your ordered pair? Well, y is 0, and we said our x was a negative 2. And you could always check it in the original equations, but this does check. And here they're showing you that right down there. Okay. Still nothing really too hard here. Now as we get to example 5, I should say, again we have two equations, one in which you have x solved, and then we have a fraction. Okay, but they want you to use substitution. And we can go to the next page. So, in that other equation, we will substitute for our x value what we said x equals, which was this. Now notice when we take 1/2 of 6, we get 3. And 1/2 of 2y, we get y. And we get minus y and equals 3. You might say, uh-oh, something's happening here. Because the y's cancel out and you get 3 equals 3. That's strange. But is 3 equal 3 a true statement? Yes, it's true. Now, when we are solving by substitution and other methods, if we end up as we do here with a true statement, this is telling us that our equations are the same line. Ending up with a true statement tells us that the equations are the same line. So that's what they're saying. So these equations are identical. So how many solutions did we say this would have? An infinite number of solutions. And how do we write our answer? Again, when you end up with a true statement, we use set builder notation, and we can write either one of the two equations because in fact they are the same equation, just in different algebraic form. Okay, now as we look at example 6, again they are in standard form. Now they wanted us to solve for one of the letters. So we are going to solve for the letter Y. Now when we do it, we get this. When we replace Y with a negative 1/2 x, notice what happens. This is our first equation. We're replacing the Y with what we solved in terms of x. Here it cancels out and we end up with a 6x minus 6x equals 5. 0 equals 5. Is this a true statement? And the answer is no, this is false. Well, when you use the substitution method and you end up with a false statement, this indicates that the lines are parallel and there will be no solution. And that's what we see here. Now, in your math lab, they're going to indicate that no solution will be one of the options. And another way to write it would be an empty set or a null set. Okay? When you work it through substitution and you get a false statement, that indicates no solution. And again, you'll be doing some practice. And in our next section, we'll look at another way to do these that I think is very, very useful as well.